So today we're going to be treating indices. Indices is the plural form of the word index. Hey, welcome to Academic Digest class. So I said today we're going to be treating indices. And indices is the plural form of the word index. Another name for the word index is exponents. Indices talks about the power of numbers or variables. So whenever any number is raised to any power, we are talking about indices. So under these indices, we have certain rules, which we call the rules or laws of indices. Rules or laws of indices. And the first rule is what we call multiplication rule. Multiplication law. This law states that provided the bases are the same, add the powers. Let's say a raised to power 2 times a raised to power 3. Provided the bases are the same, that this is the sentence saying making the base to be 1, then add the powers, which is equals to a raised to power 5. So instead of that, your secondary school where they come and do a times a, then a times a times a. By the time you check it, multiplication of variables add to the power, while addition of variables add to the coefficient. So this is multiplication, and when you check it, this is a square, a3. If you bring it together, if you add up everything, it's a raised to power 5, which is the same thing as this a raised to power 5. So that is for multiplication law. So the second rule of indices is what we call the division law. And this one states that provided the bases are the same, that we should just subtract the powers. So since I have a raised to power 3, this is now going to be a raised to power 3, and this is 4 minus 4, which is equals to a raised to power minus 1. If we want to do it, let's say we go a times a, your secondary school mathematics, all over a times a times a times a. Cancel, 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 cancel. We are left with 1 over a. And 1 over a is the sentence saying a raised to power minus 1. And that leads us to what we call negative power law, the third law. Negative power law. Negative power law. The negative power law simply states that anytime the power of a variable or a number is raised to a minus, that it has a numerator which is equals to 1. So if I have a raised to power minus 1, it has a numerator, which means that it's now 1 over a raised to positive power. Then raised to power 1 is that thing. So if I have a raised to power minus 2, the law states that it has a numerator which is 1 all over a now raised to power of a positive index. So if I have a raised to power minus 3, is the same thing as saying 1 over a raised to power 3, which means that if I see, for example, a raised to power minus 20, is the same thing as saying 1 over a raised to 20. And what if I see 1 over a raised to power m? It is the same thing as saying a raised to power m. That is negative power of m. So we move to the fourth law. The fourth law of indices. The fourth law of indices is what we call the zero power law. Another way to get an understanding of this negative power law is that if, for example, I have, let's complete this before we move to the fourth law. For example, I have, let's say, a raised to power 0 minus n. Notice that this is the same thing as saying everything here, a raised to power 0, everything here will give me a raised to power minus n. And we know from the next law we are going to solve, a raised to power 0 is equals to 1. And if that is the case, this is the same thing as saying everything here a raised to power 0 over minus n, sorry, everything here is the same thing as saying a raised to power 0 all over a raised to power n. That is applying division law. So this is going to be 1 all over a raised to power n now. Now be a raised to power n. So you see 1 over a raised to power n. And if you check it, this is now the same thing as saying a raised to power minus n. So let's move to the fourth law, which we call the zero power law. Zero power law. Zero power law simply states that any variable or number raised to power 0 is equals to 1. For example, if I have a raised to power 3 divided by a raised to power 3, we know that applying division law, this is the same as saying a raised to power 3 minus 3, which is equals to e raised to power 0. And notice that anything divided by itself is equals to 1. So you see that if you apply indices, this is a raised to power 0, and which is equals to 1. That is zero power law. The next law is what we call the power law, or you call it the power law. Number what now? Number 5. So in our next class, we'll be doing problems on indices. So power, I like to call it power law or power law. This power law simply states that if I have a variable a, for example, I can use b, I can use any variable. What you call variable in mathematics, in English you call it alphabet. If I have a raised to power a power, and let's say this is raised to another power, power law is saying that we should simply multiply the powers. So if I have bn 2 plus 1 equals to a 3 raised to power 2, this is the same thing as saying b multiplied by 2n plus n is equals to a raised to power 6. And if you check it, applying multiplication law, this is the same thing as saying b2n times b raised to power n equals to e raised to power 6. So this is an example, and it's best left this way. So that's power law. Now the sixth law of indices is what we call distributive power law. And distributive power law works for multiplication and division, so it doesn't work for addition and subtraction. Distributive power law simply states that if I have a plus ab all raised to power mn, that this is the same thing as saying a raised to power mn and b raised to power mn. And if I have a over b all raised to power half, now this is the same thing as saying a half all over b half. And this is the same thing as saying root a all over root b. So this takes us to the seventh law, which we call fractional power law. Fractional power law. Fractional power law simply states that if we have the power of any variable or any number, say b, to be raised to a fraction, let's say 1 over 3, that the denominator, the one down, will become the roots, while the numerator will become the power, which means that this expression will now be the same thing as saying cube root of b raised to power 1. So it also, for example, if I have a raised to power 3 over 81, a fractional power law says that the denominator becomes the root. So this becomes 81st root of a, and the numerator becomes the power raised to power 3. So that is fractional power law for you. So the eighth and the last law is what we call the reciprocal power law. The reciprocal power law. That's the last one. The second to the last one, rather. Reciprocal power law. And this law states that if I have, for example, 1 over b over a, that I'm not supposed to come and say that this is the same thing as saying 1 over b divided by a, because if I do it, I'm not dividing the whole thing, but rather this is the same thing as saying 1 over b. 1 is being divided by b and b is being divided by a. So I'll place it in such a way that b can divide a. So this is what it's saying. So reciprocal power law will now give me that this is not a over b. See, I've reversed it. So if I have 1 over 8 over 1000, reciprocal law is saying that this is going to be the same thing as saying 1 over 8 times 1000, which is the same thing as saying 1000 over 8. And when you do it 2 here, 4, 2 here, 500, 2 here, 2, 2 here, 250, 2 here, 1, 2 here, 125. So the last law, which is the ninth law, the last law is the last law of indices is the law of basis, or the base law. The base law. So the ninth law, the base law. And this law states that if we have an equation, say a raised to power 2 equals to a raised to power 3, that provided the bases are the same, that the powers are also equal. So this is going to be the sentence as saying equates the powers, so that we now have 2 is equals to 3. If I have a raised to power 2x equals to a raised to power 4, equals to a raised to power 4, base law is saying that since a and a are on both sides of the equation, that their powers should now be equal. So this is going to be 2x equals to 4, making a subject of formula with divide both sides, so that x is equals to 4 over 2, and this is going to be 2. So thank you. In our next class, we'll be treating problems under indices, indical problems, indical equations, and indical equations leading to quadratic equation.